So we have given an overview on the issues that arise when you use deep learning networks as a black box, for example, for research, which is my most familiar subject. But there are other limits to the use of deep learning networks for anything. And I wanted to call your attention to a few of them. These 4 papers that I will mention now deal with attacks on deep learning networks, and they, in my opinion, speak about the differences in how we perceive information and how deep learning networks process information. Because of this intuitive idea, we tend to think of deep learning networks as having some entity and being basically some kind of people, which they are not. And for example, they don't perceive anything. They process information in a way that we tell them to do. And the final results sometimes look like what we do. For example, for the observer study, we ask the humans to classify the bushes into their categories, and we could get the same results from deep learning networks. But that doesn't mean that the process that happened within the deep learning networks was the same that happened within the brains of the human observers. And this is very important. And here are some very clear examples that also illustrate the limitations of deep learning networks. For example, the 1 pixel attack is a very famous example. This is also an archive paper, okay, that you can go and check and is publicly available. And these people basically used something called generative adversarial networks to modify images from one very famous image dataset called CIFAR by just changing 1 pixel in every image. Okay? Not any pixel, but 1 pixel that was very annoying for the original deep learning network. Okay? So it's not changing a random pixel, but changing 1 pixel, choosing another deep learning network to using another deep learning network to choose what pixel in the image is most annoying for my image classification network. But what they achieved was that by changing this very, very well chosen pixel, they could change the classification from deer, for example, in this image, which it actually contains, to airplane, just by changing 1 pixel. Or in this one, they could change this classification of bird to frog by just changing this. Or a cat could become a bird. A sheep could become an airplane. Or a cat could become a dog just by changing 1 pixel in the image and using these other deep learning networks to choose what pixel was most adequate to perform this attack. These are called attacks on deep learning networks. Okay? My point here, apart from this being a very interesting paper by these guys, is that this is very different from the way humans perceive images. If we know that this is a deer and someone changes 1 pixel, any pixel in the image, it's very unlikely that we are going to stop realizing that that's a deer and think that it's suddenly an airplane. But deep learning networks process information in a different way. Another similar example is this paper called The Elephant in the Room by some authors with very good sense of humor. Both this paper and the previous one are from 2018, and all the papers that I'm commenting here are available on archive. Here you have the reference. These guys used a system for object detection, okay? And then, jokingly, and also very interestingly, they placed an image of an elephant on the same, see the elephant here, the elephant in the room. They used this sub-image of an elephant and placed it there, and sometimes they achieved a position where the elephant was not identified at all. So the goal of the network was to find the things in the room and identify them, and sometimes if they placed it in an annoying enough position, the system could not identify the elephant in the room at all. And sometimes it could, okay? Or sometimes the placing of the elephant could change the probabilities of the detection of other objects, okay? So by placing a sub image inside of an image, they could create very annoying situations for the classification networks involved. So again, the perception of deep learning networks is very different from, sorry, I don't want to say perception. The way deep learning networks process information is very different from the way humans perceive. We do perception. Deep learning networks process information in a way that's not the same, although sometimes the results can make us think that we are doing the same thing. We really are not, and these are very, very clear examples. You may be thinking, okay, but you need another deep learning network to trick classifiers or object detectors into mistakes. Well, not always. Other attacks are in the real world. For example, these other guys, again available in archive, went and used stickers on traffic signs to fool deep learning networks that were supposed to be automatically detecting those traffic signs. And this is a very important application, for example, in self-driving cars. Okay, so this has very significant implication. No fancy generative adversarial networks here involved, just people placing stickers in annoying places, and that consistently and significantly decrease the performance of deep learning networks, which has many implications. One of them is that, well, if we are to have self-driving cars anytime soon, we have to be very careful because small perturbations on the traffic signs can get them not to see them. Okay, so that's something that has to be taken into account, and so on and so forth. This research is ongoing. The previous papers are from 2018, ones that I used to know, and that's a lifetime in deep learning terms. But for example, this one is from 2023, again archive, also published in other places. And these guys do a bit of run through the different types of attacks, which ones are deployable in real life and which ones are not. They, for example, speak about this sticker, the patch attack. This placing stickers, they call it patch attack, and they can also think about the possibility of scratching traffic signs, for example, to get classifiers to fail in their classification. So I would say the problem here is that the way images are processed inside of classifier is quite global, because of this data seen as a matrix, and this matrix going through all the nodes in the deep learning networks and being modified as a whole and changing the parameters of the system as a whole. If the image as a whole changes, even if it's in a way that we would perceive as unimportant, then that affects the results, and that has a very significant impact. So, limitations of deep learning networks. Well, first one, we saw that using them for something practical is not completely straightforward. Second one, the way information is processed by deep learning networks is not the same way as we perceive information. Deep learning networks are not intelligent for many definitions of the term, or for, I would even say, any definition of the term. If you ask a lay person, they can do some very narrow specific tasks very, very, very effectively, but there are a lot of things that they cannot do. They cannot process information in the same process visual information in the same way that we can, although they can do it in another way that sometimes arrives to the same results. They cannot do extrapolation, for example. This is a whole other area, but if you train a deep learning network to recognize cats and dogs and show it a picture of a bird, it will not know what to do with it. It will give a very bad result. Okay, here I fell in the very usual trap of humanizing deep learning networks. The deep learning network will not know what to do. Deep learning networks don't have agency, don't think, don't act by themselves. They are just a collection of instructions that we have prepared. So they cannot think, they cannot plan, they cannot extrapolate. If the thing that you want to do is not in their training data, there is nothing that you can get from them. Okay? Deep learning networks are a super useful tool. They are also, at this moment at least, very narrow in scope. They can do some very specific things very well, not so good at general things.